So 24.10 is asking, what is the electric flux through the surface shown in the figure? Assuming here that the electric field is 200 newtons per coulomb. So one of the key things about understanding the setup of this problem is you have that flat square plane, which the area vector is always going to be perpendicular to the surface of that. And then you have some electric field going through that plane at an angle of, it shows 30 degrees. One of the trickier things about this problem is understanding that when you're calculating electric flux, the angle that matters between those two vectors is the electric field and that normal. So the angle they give us is that 30 degrees, which is the angle between the flat plane and the electric field. And you can see on my picture on the right, I've written in that top 60 degrees, and that's the degree that's actually going to matter when we're solving this. So yeah, getting started with that. So it's a very simple problem. We've defined the electric flux as being that perpendicular E times A, which that is very similar to the dot product. It's going to be calculated in a similar way, and that, of course, equals EA cosine theta. So as we talked about, that theta is just going to be 60 degrees, which you can do by just using your right triangle geometry logic. And then pretty much all you have left is plugging stuff in. So the first thing is just that E value. Then one thing that you always have to remember with these to make your units work out is converting from centimeters to meters. So making sure you did that is important, and then multiplying by cosine 60. And that leaves you with a total electric flux of 1 Newton meter squared per coulomb. It's a pretty simple problem overall. For me, the most complicated concept is just electric flux in general. Essentially, it's just the measure of the electric field through a given surface. But it's a little strange since the electric field can't actually flow. It's essentially just a way of describing the electric field strength at any distance from the charge causing the field. So it's kind of it's a more abstract number that we're solving that helps in other calculations somewhat. But yeah, that's pretty much it. Thank you for listening.